I want to shoot this video on how to check salinity when making GANs. I have run into situations where sometimes I thought it was important to get the salinity right on certain GANs that I've run. And I noticed that it's easy to set up the salinity when you first do a GANs job, because you can put in a known volume of water in milliliters, and you can put a known weight in salt in grams, and you can get the salinity exactly right. But what I notice is that the salinity will change over time. Like what will happen is some of the water evaporates out of the containers, and some of the salt gets pulled up into the water vapor, and that leaves the containers. And so if I would refill and top off these containers with fresh distilled water, the salinity would be different than when I first set it up. And so I would like a way to bring it back the way it was. So I've got a couple of tools here that I use, and I've learned how to check the salinity. And another reason I like to be able to check the salinity is because I like to reuse the GANs wash water. It's a way of reclaiming it, so it's being put into use. And another reason why I like to be able to check the salinity is when I'm washing the GANs, sometimes I might lose track of how many times I've washed it. And all I got to do is use one of these tools here, and it will tell me when it hits 0% salinity. So I'll know exactly when the washing is done. So it doesn't matter so much if I lose track. So I have a couple of tools here that I use. And this first one here, it's called a hydrometer. Now this is a real simple tool, and it's very inexpensive, and it has a scale on here called specific gravity right here, and you use the specific gravity to determine the salinity. But it's not a straightforward measurement, so you have to convert the specific gravity into salinity. So that's the only thing I don't like about it. But other than that, it's pretty old school, and it's been around for a long time. Now there's another tool that I have here. It's called an optical refractometer. Now this is also very inexpensive, and they're quite common now, and so it's very easy to use, and it does read salinity directly off a scale that's inside here when you look inside this eyepiece. Now the way this works is you put a few drops of test water right here on this prism, and then you shut this cover, and then you look into this eyepiece into a bright light, and you will see a scale in there. Now I'm going to pause the video for a second, and I'm going to put up a graphic so you can see this scale. This is what you will see when looking into the eyepiece. The salinity is read at the divider between the blue and white fields. In this example, the salinity is 10.8%. So anyway, with this particular optical refractometer, it has a scale on it from 0 to 28%. Now there's a number of other optical refractometers that you can buy for checking salinity, and most of them are only good up to 10%. Now, if you're only working with 10%, well, that's just fine. It'll work good. But in this case here, I've been wanting to set up these CUO jobs for 15%. So with this particular unit, I can check it at 10%, or I can check it at 15%, and I can do both of those with one tool. So if you're thinking about buying one of these, you got to make sure that you buy one for salinity, because they make these for checking antifreeze, and they also make them for checking beverages, for checking the sugar or alcohol content in beverages. So just make sure that you get one that checks salinity. And there's also, these units have, this is marked ATC, and that stands for automatic temperature compensation. So that's real handy, because what it'll do is no matter what the temperature is, it'll give you a correct reading on salinity. And I just wanted to say that if you're using a hydrometer, you also have to use a thermometer with it, because you have to measure the water temperature. So anyway, that's a little intro on the tools on how to check salinity. So I'm going to pause the video, and then I'm going to set up a demo. This is a demonstration of how to adjust the salinity when making Gans. After harvesting the Gans from a previous batch, I will use some of the wash water to top off the containers for the next batch. The salinity will have to be raised back to what it was because the wash water has diluted the salt content. First, I will top off each container so I have a known volume of water. Each of these containers holds 3,350 milliliters. Next, I will measure the salinity and then calculate the amount of salt that is dissolved in the solution. Then I will calculate how much salt I need to add to raise the salinity to the desired level. There are a couple of ways to measure the salinity. The easiest way is to use an optical refractometer. Place a few drops of the test water on the prism surface. Close the prism cover so that the water spreads out evenly and covers the entire surface. Look into the eyepiece while facing natural daylight or bright lamp. This is what I saw when I looked into the eyepiece. In this example, the salinity was 12.6%. Make a note of the reading for reference. Another way to check salinity is with a hydrometer. It's not as straightforward as the optical refractometer. It measures specific gravity, which has to be converted to salinity, but it is a less expensive option. Gently lower the hydrometer into the water so you can read the specific gravity scale. When the hydrometer settles down, read the specific gravity at the point where the water level meets the scale. Make a note of the reading for reference. Always take the temperature of the water when using a hydrometer. A dial thermometer from a kitchen supply store works well. Place the temperature probe into the water and hold it until the temperature reading stabilizes. The water temperature was 50 degrees Fahrenheit. This hydrometer is calibrated for 68 degrees Fahrenheit, so I will need to adjust the reading. The specific gravity will need to be reduced by 3/1000ths. That's a reduction of 1/1000th for every 6.5 degrees difference. This is according to the instructions that came with the hydrometer. The specific gravity is converted to parts per thousand. The calculation was made using a free online resource. The link will be in the video description below. Parts per thousand literally means grams of salt per 1,000 milliliters of water. Parts per thousand converts easily to salinity. You simply divide by 10. You just move the decimal point one place to the left. That's because for every 1% salinity, there is 1 gram of salt per 100 milliliters of water. So in this demonstration of using a hydrometer, the salinity was 12.67%. The result is pretty much the same as with the optical refractometer. Once we know the salinity, it is easy to calculate how many grams of salt is in the container. We can also calculate how many grams of salt will be required for the salinity we want. We simply add the difference to the container for the target salinity. This can all be done very easily using a spreadsheet. The salinity reading of 12.6% is 126 parts per thousand. The spreadsheet shows that I have to add 80.4 grams of salt to increase the salinity from 12.6% to 15% for 3,350 milliliters of water. Using a digital scale set for grams, I weigh out 80 grams of salt. I'm using a kitchen scale and it doesn't show tenths. Simply add the salt to the container and stir it with a metal spoon. Stir for a few minutes until all the salt is completely dissolved. After a few minutes, the target salinity is reached. The process is repeated for each container. I hope you liked the video. Thank you for watching.